early days for what we these days call new space. And
Yes.
we can argue about that expression, whether it makes sense or not, but let's say it anyway. So I think, yeah, SpaceX had already finally flown the Falcon 1 on the fourth attempt.
Yeah.
They may have won, or I think they did their first financing round in 2008, but they were nowhere near where they are now. So that was still an aggressive bet to take. So let me ask you, what gave you the comfort to take that bet? And then how did you end up choosing Spire's business model when, of course, you could have chosen other space sectors as well? And as we know, of course, a lot of people got attracted to things like the launch business, right? You build rockets, it's very exciting. What made you choose? What was the process and the thinking you went through to come up with Spire?
So the first thing that really helped me was that I lived through, not very actively, but partially actively, but mostly by experience, through the transformation from mainframe computers to personal computers to the internet. Mm-hmm. So when I was at CERN, we had this massive supercomputer, a Cray, between 3 layers of security. And today I carry a Cray that is 10 times as powerful as the Cray 2 we had there in my pocket. Mm-hmm. I had built the early PCs. I had been at the conferences where people said, there is a world market for 3 computers, and no one needs them at home. So I had seen what Moore's law, what an exponential improvement in capability for a fixed price and size point does to an industry. And I just started to see exactly the same thing happening in the space industry, finally, which I had monitored for many, many years, literally a few decades at that point in time. And so that gave me then the confidence that, here is something happening. And given that I had been passionate about it since I was a teenager, there was just a merging of a passion for something that finally had come to the first inkling of an exponential stage. And then when I got my graduate degree in space science in France, I did a piece of research where I looked at all of the capabilities of all of these small satellite missions that had been done since the invention of this new standard that they call a CubeSat. Mm-hmm. And what I saw was a very steady exponential improvement, 10x performance every 5 years, which is faster than Moore's law. And when I talked with 100 experts from the space industry, 111 or so I interviewed, they all saw a very linear, slow progression of capability.
Right.
And that was a classic disruption, Clayton Christensen difference between an exponentially improving technology and the linear perception of the rest of the world. And that gave me the confidence, yes, here is a business, here is a technology that is capable of really solving problems on Earth that are relevant. Because I projected forward, what will the capabilities be in 5 years and in 10 years if I follow this 10x every 5 years curve? And it was blindingly obvious that by 2015, by 2020, those devices will be highly capable solving real world problems.
Yeah.